So good afternoon and very welcome. It is a real honor for me to introduce today's speaker, Professor Andrea Rinaldo, who is Emeritus Professor at the University of Padua and at the Swiss Federal Institute of Technology in Lausanne. Professor Rinaldo is an internationally recognized scholar whose work bridges hydrology, ecology, and environmental justice. His groundbreaking contributions have earned him membership in prestigious academies, including the US National Academy of Sciences and Engineering, the Royal Swedish Academy, and the Accademia dei Lincei, as well as research fellowships in renowned institutions such as the Massachusetts Institute of Technology and Princeton University. In 2023, Professor Rinaldo received from His Majesty the King of Sweden the prestigious Stockholm Water Prize. Today, in his talk Reflected in Water, Development, Resilience, Inequalities, Professor Rinaldo will explore how water shapes our environments, our health, and the social structures we live in. He will challenge us to rethink how we value natural capital, how we address inequality, and how we envisage a more just and sustainable future. So please join me in welcoming Professor Andrea Rinaldo. Thank you very much.
Thank you very much for this lovely introduction, actually. I'm very appreciating. And yes, the picture seen here is a particular reflection, in fact, and I always seek excuses for speaking about my hometown, the city of Venice, which is a paradigm of fragility in the face of phenomena that we'll be exploring, however briefly, today. So the pathos of reflections in this case are one of the things that we have in mind. And my thesis, essentially, the one, my aim is that I'll be trying to chase through the talk, will be the development of a broadly inclusive rethinking of distributive justice on an issue, which is the water resources management, and through it, justice in issues that are related to that, chief and foremost, migrations, inequalities, gradients of richness that are the engines of migrations worldwide, seeking for a better world, of course. And the compelling evaluation of ecosystem services is another issue that, reflected in water, gets a particular value and relevance, and the economics of biodiversity, of which we will briefly speak about, hopefully. Shall I direct here? This one? Okay, sorry, it was just, I swear it's the last slide I put on Venice, in fact. But that introduces to one of the things that I had in mind. This is, there's something tricky about this picture taken during the lockdown of the COVID-19. It's capsized, it's upside down. The photographer wanted to, it gives a fair impression, in fact, if you look carefully, about the suspended world of those days, in fact. And why this is important? Because one of the key issues that I want you to draw your attention of is the rapidity of the changes. Why? Because pandemics have always been the history of history, meta-history, if you want. And the Black Plague took maybe 40, 50 years to land in Europe and decimate, in fact, the population of the time. Not decimate, but halve the population of Europe, actually, at that time. And why this is particularly important? Because it took only one flight from Wuhan to Toronto, plus or minus a few days of incubation, for making the COVID-19 a pandemic. So rapidity is the key. As we will see about the issues I'll be discussing about the climate change, which is not something we'll look forward at a distance, but something which is upon us already. And in the case of pandemics, it's explained quite clearly. Everything is accelerating at a pace which is unprecedented. And what I would like to, the dumb engineers love diagrams, as you know, and I am one of those. But what I'm saying is that I want you to retain not units of measure, not details, not the particular values. But there's something which I want you to think about. There is a huge number of indicators, whether socioeconomic or biogeochemical or related to the measures directly of the impact, the anthropogenic effect on the change of the composition of the temperature, etc., or in perturbation of the biosphere, in fact. And all these diagrams that I'll be showing you, in orange you will see socioeconomic ones, and we're talking about population, for instance, gross domestic product in a sense, foreign direct investment, population, the use of water, the use of energy, you name it. Whatever you take, telecommunications. And what is surprising about these diagrams that became iconic and worldwide known as the hockey stick diagrams, because of what happens is that since we started measuring the more or less roughly the beginning of the 18th century, Padua, the Padua spirit thing is that because the first chair ever in hydraulics, which is my discipline, is in Padua at Abate Poleni. They started measuring systematically daily rainfall, in fact, since 1710 or whatever. But broadly speaking, we have an idea of data of increasing quality about the world surrounding us from the beginning of the 18th century to now, essentially. And what you see in all these diagrams, what is really scary is the fact that we live into a quiet Holocene, flat, nothing changes for almost 3 centuries. And at the same time, everywhere in the world, you get its economic indicators jump out without control. It's the hockey stick diagram that you see in this place. So it's not the details of the units of measure, whatever I want you to retain, but the hockey stick diagram which remained. And that transports itself into measures which are directly a measure of the turbation that we see in the atmosphere. And they're talking about concentration of carbon dioxide or nitrous oxide or methane, which is 20 times more serious as a greenhouse gas than CO2, which is typically measures of concentration of damage that man has caused to its house, as it was famously said. Talking about the only one in which you do have some change is the stratospheric ozone concentration, because it's one of the few cases in which you could intervene very quickly, not touching economic interest of the highest types. It was Molina and that suggested that how to, in fact, close the gap on the ozone hole by banning a certain quantity. However, the production of CO2, methane, or nitrous oxide, it's completely out of control. Or if you take surface temperatures of the oceans, marine fish capture, the tropical forest loss or whatever, it's completely diverse. What scares and should scare everybody, it doesn't happen that often as you would imagine, especially during this political climate that we are living through now, is the fact that everything remained quiet and flat, the quiet Holocene, and then in the 50s of last century, they start jumping up at the same time everywhere in the world. That's something which has to be kept in mind. And what you're seeing here, so I wanted to quote, for the benefit of a provost who's a philosopher of science, I wanted to quote Bertrand Russell directly. I'm reading it. History can be viewed in many ways, and many general formulae can be invented which cover enough ground to seem adequate if facts are carefully chosen. That was Bertrand Russell was, in fact, in this refutation of a historic materialism, was saying that if you cherry pick as you please, you can trick anything, etc. What I'm saying is that you can cherry pick whatever you do, and these indicators, these signs, in this case, what you see is the loss of the mass converted into mass of ice in Greenland. Why should we care, you say? Well, I'm telling you why. Because if you get into a point, if you touch what it's normally called the tipping point in which Greenland will lose all its ice, which is an event which there is, in fact, geological documentation of previous occurrence of that. We're talking about something like 7 meters more sea level rise. That's again back in my mind what happens to my hometown with 7 meters or more sea level rise. Bologna is about, I guess, 15 meters, 20 meters above mean sea level, so you may be safe for a while. But the issue is that how do we cope with that? And here it is. So the idea is that what is essentially the message that I want to carry you through in this brief discussion? And please advise me when I tend to get carried away. When time comes, you just where is she? Here you are. Okay, you just you let me know. Okay, so what are we talking about? Reflected in water means that we have to study particular phenomena. We're not talking about the theory of everything, but we are talking about specifically about three things: floods, droughts, and the fair distribution of water, as I'll be trying to somewhat convince you they are related. And here it is exactly. So first of all, why there is an issue that connects all these patterns? You connect the dots, and it's the fact that a physical law which cannot be bypassed. It's inescapable, in fact. It's called the law of Clapeyron, if you want Clausius to a certain extent. That means that for every degree more of temperature of the atmosphere, which is in fact the effect of a greenhouse gas. It's an effect of the accumulation of a trapping of heat, which is generated by whatever happens in the atmosphere. For every degree more of temperature, something which even the butcher in Melbourne knows it's hotter and hotter and hotter. We had 8 years in a row in which the mean temperature, the mean annual temperature is increasing. The highest temperature, there is the world record of a warmest day ever, poles included, 17.2 degrees was last year. Every year is one of those, and this is upon us. And the point is that for every degree more, that atmosphere holds from 6 to 8% of water vapor with it. It is water, essentially, in one of the phase transformations. So if you face any kind of cold front, you're going to have stronger rains. Stronger rains selectively, and I'll be getting to something which is dear to Bologna, in fact, because it depends how this generates. But what happens that you see in here, it was in Pakistan, the monsoon, in 2023, it was absolutely disastrous. And what you see in here, like in this picture, is you've seen it like something like holding up for months. And now by chance, I'm showing something which happened not very far from here. It's the fiume Idice, the river Idice in Romagna on May 13, 2023, when it was a major effect, etc. And this is particularly important because what happened is that you had 66,000 landslide in an event generated right after a long spell of drought. And I'll be getting back to that in a minute. But what happened is that this hits something which is fully clad into the Anthropocene. If you think that, look what happened in this case, like much water, a breach in the levee. But what is absolutely unusual is the fact that the Anthropocene pitches in, because the river abandoned the riverbed. Not a drop of water remains in the due course. And that means that coupled with what's happening to the climate, what we have done to the climate, that's what we have done to land use. What we have done to the respect and the land use and land cover, which is another issue which we should be clearly taking that into account. And this is an interesting thing because the idea that natural systems fluctuate within unchanged envelope of variability is a foundational concept in what we teach the students in how any single water resources manager in the world is trained about. The only thing is false. It's not true anymore. And that was nicely synthesized with what seems like a joke, but it is not. It's a phrase which can be attributed to a baseball player in the US or a poet and philosopher in France. It's called the future ain't, that is not what it used to be. The future is not what it used to be. Il futuro non è più quello di una volta. And it sounds like a joke, but it is not. It means that whatever you have collected about the variability, the envelope of variability of a natural phenomena, cannot teach you what happens in the future. The past does not exist, says an Italian poet. And that means that you have to rethink everything that you have done in that respect. And there is absolutely evidence that you're not talking about something which, like the crowds and you jinx or whatever. climate change is already upon us. It's not something which you have to expect will happen. You have people that deny it and whatever happens. That's exactly what it happens. And I'll be getting back to the merchants of doubt, in time, because maybe the negationists, for those that deny the existence of that, they can do it out of ignorance. They can do it out of deliberate plan. And these are the merchants of doubt, sensu, Naomi, Oreskes, in fact. And there's something else I'd like to touch about in this case. And talking about inequalities, first of all, well, everybody in this room living in dear Italy, in fact, assumes the fact that if you open the faucet, you get the water you need of the quality you need. But, and that the dotation, that is the liter per day per person that you have in our country, is about 260 liters per day per person. You use, on average, 260 liters per day. But that's not what happens in the global south, in fact. What you're seeing here is taken in sub-Saharan Africa, which by the particular division of labor that you have in those countries, in fact, the water supply to the household is provided by the women. And that means that the dotation in sub-Saharan Africa is what a young lady or an old lady can carry on her head, maybe walking, maybe a sizable distance, in places in which it's a filthy, completely unprotected well, as you see here, which is quite remarkable, in fact. This is the basis of the reasons why people want to leave those places. You don't see future. And if you assume, as economists do, and it's absolutely, economists tend to, certainly some, many of those among you, that they quarrel about everything, not about the fact that the water consumption is a good proxy for the social and economic development of a community. And, oops, I think I skipped. No, I think I canceled a slide I thought I had. And talking about, we said about floods and droughts, it's technical and I won't pursue that, but clearly the changes in extreme in floods and the changes in extreme in the scarcity of water are related to the same law, which is the Clapeyron law, in fact, that you had in that place. So what happens is that, and you have different aspects that you have to face, and the elements of water cycle, such as precipitation, soil moisture, stream flow, and groundwater storage, they have a different delays that you see in the conceptual diagram, which was very important. What I'm saying is that, talking about, again, the Russellian paradigm that you've seen, now we have a very strong ability to, largely based on remote sensing, direct observation of what happens to nature in the thing. Like, for instance, we can even measure in real time, remotely acquired and objectively manipulated photosynthesis activity above ground, biomass, and the likes. But we've never been so empowered with our knowledge, just failing to have a deeper, in fact, ability to convince our fellows that the time is ripe for something major. And this is another example which is also relevant to this idea of equality, which is quite interesting. What you see here, the colors veering out, by the way, this is the meteorological drought, that is total amount of a deviation from the established average of a mean precipitation in a year-long period around 2022 in Central Europe, and this is a snapshot of that. Veering towards the red means that you have below average, significantly below average precipitations, and blue means above average. And why this is important? Because in 2024, you have heard, in Italy, you have heard about this disastrous drought that hit Sicily, for instance. It's easy to remember the bad times, but you forget easily the good times. What happened a year before was the fact that Sicily was doing extremely well, like Sardinia, the other island. The opposite happened to Central Europe. That is, the message is, one of the consequences of this continuous increase in the temperature of the atmosphere and the related hydrologic events is the more and more erratic character of rain and snow, with major consequences on our ability to master these processes. And this brings us to sub-Saharan Africa, where I did field work for a long time until I've been 17 years in the École Polytechnique Fédérale. I could afford every single year expeditions and for a long, long time. Why this, in a sense, sub-Saharan Africa is the symbol of our responsibilities. Jonathan Ledgard, who is a master of contemporary African thought, was the chief correspondent of The Economist from Africa for many moons, wrote not long ago that while we speak 800 million Africans will live within 10 years in cities that do not exist as of today. In 10 years. And that's why, in fact, the idea is that that changes the paradigm about mitigation or adaptation, because everybody, if you talk to dur and pure environmental or meteorologist and climatologist, in fact, he would tell you, no, forget about adaptation. The issue is mitigation, that is solving the problem. Do you expect those cities in Africa to be carbon friendly, to be reducing emissions? Do you believe that the global north has a clout on the global south about the destruction of the conservation of variables unless we provide fundamental resources for doing that after we have destroyed all our resources and their resources in large part? I do not believe that mitigation can be pursued, especially in the particular uncertain climate that you see in here. So adaptation is a process keen to a new level of awareness and awareness of the rapidity of the changes, as I was telling you before. And so the message is very clear. That is, climate is changing rapidly, very fastly. And so should we. Not giving for granted the privileges, like the supplier we're talking about clean water in the quantity that you have to have, or you can't assume all the traditions of the places or something that has been values that have been established for generations, etc. The rapidity of a cycle means that you have to ask yourself questions like, what kind of agricultures should be feasible, in fact, in the common future? It's something which unsettles deeply primary production and unsettles clearly strong places and power centers in any country of the world, not necessarily, not only Italy, of course, in that planet. But how, in fact, can we make a compelling case of that? Now, one of the points is that, and this happens in a place which is particularly, in fact, revealing in a number of cases, etc. But it is the future large-scale water resource. With, for instance, questions like, will large-scale water resources management plans take into account of the conservation of biodiversity? Because they don't now. Well, do we realize that, for instance, the propagation of waterborne disease, which is another about the fair distribution of water, it's an issue with which I will close my conversation. In fact, it's the fact that the issue of clean water, it's socially biased, because in the world this is what you bring into a place, and you can clearly realize that for instance, have we learned something about, for instance, can we read in the map of a river, for instance, the capability that those transportation of waters will tell you about the propagation of deadly or chronic poverty-reinforcing waterborne disease, because that's what happens. For instance, in the universal shape of the river networks, and God bless them, that's why they gave me the prize in Stockholm. It is showing that this universality of form oozes on the function as ecological corridors. For instance, in the rivers you can see the patterns of migrations, even historic migration, including the Neolithic transitions that show the communities the way we see them today. And that hinges on the fact that we need to discuss the quantitative evaluation of ecosystem services, in fact. Are we inching about a fair distribution? Key to that is the fact that we should be able to put a price tag on the values of the ecosystem. When you say that something is priceless, it means that it has no economic value. And in this work, the work of two giants of the field, Partha Dasgupta, emeritus professor in Oxford, and Simon Levine, still active in Princeton, in fact, they started showing the obvious, that is economic indicators that omit the value of a natural capital do not give a sense or even a close approximation to the poverty, the richness of the poverty of nations. And so in reality, you have to rethink. There is something which the capability of distinguishing between development thinking and environmental thinking that are being clashed against one another is something which prohibited in the past. The idea, and I show you what is the origins, I believe, in that system. But certainly, key to that is to master the capability to assess and reliably predict the spread of biodiversity, the spread of populations, and the spread of waterborne disease. Scenarios of economic and water development, of human mobility, for instance, of awareness, of a mechanism of infection, or proper education systems, which we never forced. I'll be closing you with a slide which is dramatically revealing, in my view, or improved or worsening water sanitation hygiene conditions. So why this became so strong? And became so strong for a reason. I would call it the curse of a Kuznets curves. Kuznets was a legendary figure of economist, expatriated from the Nazi Germany, and then a professor at Harvard. He got one of the first Nobel Prize, or the Nobel Prize for economics in there. These curves in which you can somewhat simplifying something of a kind of a diagram that you see in there. If you put into a relationship inequalities and income per capita, that is any indicator of richness, collective, whatever, individual, average, as you want. Kuznets came out empirically with an evaluation of those curves being concave down. 5 minutes, okay, I need to run. But anyway, but this is the point I want to make, and then I'll be running to the other. That is, in a sense, that means that get richer, in the end, problems will mend away. Enter Thomas Piketty, which remade those calculations, and he found out that there were artifacts of the fact that the data was the recovery of societies of the Second World War. It's false. 80% of wealth sits on the 20%, the 80-20 rule, 80% of the richest persons in the world, anywhere, in Bangladesh, in the US, in Australia, in Italy, wherever you want. Rapidly going into the system, only to say that in these three, I'll be only jumping through that to get to my point. What is fantastic is the fact that you have amazing data, remotely acquired and objectively manipulated into the geometry and the function of nature, in fact. And you can start from the infinitely small, what you can do on a glass plate, on one of those plates, that was done in my laboratory in Switzerland, and it can apply, and it can apply to the scale of a Mississippi, like in this case, in which you even see relationships. Of course, correlation is not causality, you may call, but in this case, what you have, you see the color codes, in fact, LSR, meaning local species diversity in the Mississippi, and AARP is annual average runoff production. And what you see doesn't take a statistician to see if there is a deep correlation. Everything finds a value in water. You can have it even if you do it you can have bacteria running on a scale of a few centimeters, in as much as in the Mississippi River basins, in this case it was the propagation of a particular invader, a very, very competitive invader in the past. And then what's something clearly, there are diseases like schistosomiasis or bilharziose, which is poverty reinforcing, in fact, in which I'm talking about inequalities in which 80% of the cases worldwide are in Sub-Saharan Africa, in fact. It's a disease which has a very interesting, that's very studied because it's very interesting. It has two larval phases, and it has the main host is the human gut, and then you have like a particular a particular freshwater snail, but it's like a regenerator of a signal that generates how this is done. And what happens is that it's very clear, for instance, that there is a clear relationship, unmistakable, between schistosomiasis diffusion and water resources development. What happened in Burkina Faso is that Compaoré, then dictator, in fact, got a gigantic funding from the World Bank to finance 15,000 small dams. You see one in there. I took a picture, so I was there, so I know what I'm talking about. And what happened, in fact, everybody saw the advantage that the gross domestic product in Burkina Faso has jumped. But because nobody placed into account the cost of disease, because those irrigation canals expanded dramatically the range of a disease, of a poverty-reinforcing disease. So you have to make your calculations properly. And at the same time, even acute disease like cholera, which is my last example, and I'm rapidly running to my last slide, and I was there. What you see in here is that cholera is a particular case in Haiti, in this island, the poorest country in the world, which was devastated by an earthquake that killed 100,000 people and destroyed whatever remained of any kind of infrastructure in the zone that you had in the place. And what you see in here is just as stupid as possible statistic you have. You can have it from the Pan American Health Organization, day by day number of certified cases in Haiti at the time. It was a majestic event. Haiti had been cholera-free for 200 years, and we planted it through asymptomatic carriers of a disease, of a peacekeeping forces that the UN nations sent there to prevent looting, and got cholera in the damn place. And what you see in here, you see the rivers. The propagation of the thing is completely written in the shape of a river, so tools like the ones that engineers typically use about human mobility, about population and whatever can be done remotely, etc. And we have an unprecedented ability, what you see in here, of making predictions. This is computer data and modeling approaches. Will allow you to make sound decisions about containment measures in all cases. But there is a capability on that. So, and I'm coming directly to my conclusion, which is this picture here. So my conclusion is that the management of water resources, as I said, floods, droughts, and the fair distribution of water in a broad sense, in fact, is a powerful tool for the reduction of inequalities on a global scale, including large-scale migrations, which are due to those huge, gigantic, unacceptable gradients of richness worldwide, and which are, as my title says, completely reflected in water. And I believe that the time is ripe to rethink distributive justice in water resources management as the tool to reduce such inequalities. The first point, because we have all the tools in there. There's no excuse for not doing that. Today, and that's what this picture shows, because what I've seen in this case, this lady with red, there was at the peak of a Haiti epidemics, we're in an armored car because Terre des Hommes, who was taking us around, didn't allow us to open the shields because they could kill you, they could shoot you to steal your camera, in fact. There was in Port-au-Prince, and what I've seen in the case, a second after I put down my camera, this lady with a red dress approached that lady selling cabbages down there, showed her a Nokia 900 and got a cabbage in return as a proof of payment. And that's the synthesis of my conclusions, because today when I travel in the south of the world, I see that access to safe water distribution networks, so access to safe water, still the largest source of mortality for children, for instance, is completely socially biased. Not the ownership of a cell phone, because everybody has it anywhere in the south of the world. And who put those infrastructure in there? It's always us. So inequalities on a grand scale are the engine of migrations, and we should really think that perhaps reflected in water, we could do a much better job. Thank you.
Thank you very much, Professor Rinaldo, for this very engaging, informative, and thought-provoking speech. We will now feature a question and answer session with some questions from our PhD candidates. We have 2 PhD candidates of the University of Bologna. Federica Marino from the Department of Biological, Geological and Environmental Sciences, and Riccardo Mazzoleni, who is a PhD student at the Department of Agricultural and Food Science. Okay, you can give them the mic.
So thank you, Professor Rinaldo, for your inspiring speech. I'm here. I just have one question for you. In light of the recent floods in Emilia-Romagna and Valencia, how do you assess the effectiveness of the current hydrogeological risk management strategies in Europe, and also from a perspective of adaptation, as you told, what urban planning strategies do you consider most urgent to mitigate these effects?
Okay, you mentioned mitigation. I would call it adaptation instead, because mitigation means that you actually reduce the global temperatures. I don't think it's feasible. I think it's an assumption, probably appropriate for an engineer, not for a philosopher of science or for a climatologist, but I think it's a safe assumption. It's one of the important things. About Valencia and about Romagna, it's a completely different phenomenon. In Valencia, they were clearly unprepared. We had a flood in Dubai last year, because what happens is that this evaporation from super hot water bodies generates local phenomena, local cells, that generates events which are unheard of. In Dubai, there's no even a sewer system in the system. It was completely flooded. In Valencia, it was completely unprepared, because they are fantastic in managing droughts, not floods, and they will learn out of that. The issue of Romagna is something else. The situation in Romagna, and it requires really a specific attention which is necessary. I'm not sure that, I don't know if there is a defect of engineering, etc., but certainly what I can tell you is that this effect of the future is not what it used to be, that is the stronger floods that you have in the place are scale dependent, meaning they are much stronger for small and medium-sized catchments, because the probability that those cold fronts propagate and generate the heavier effect on a larger scale becomes lower and lower. So the Po River never had particular thing. In those cases, Romagna has that particular size, which is absolutely keen to those effects. And what happens is that, what can we do? Can we destroy whatever happens in there? Can we overnight invent it? I think that a proper, and we'll see how this debate generates. It's something which you have seen even in Ravenna, right? When in fact La Cooperativa Braccianti broke, in fact, one of the things and relieved the situation for a while, which is something which is centuries old. What happens in this case is that you'll probably have to think that adaptation means to dedicate, sizable chunks of territory in which you leave it as a potential diffusers, they call them. Something which, at least you decide where the river breaks, not the river itself, or whatever. That would be a possibility. With a particular fact, which is, of course, there shouldn't be anybody at risk, or no animal should die in there, etc., and there should compensation in the end for that. But also what scares me is the fact that the Anthropocene pitches in, because if you look at those rivers, the Idische River, when it was broken, the whole thing abandoned the thing. That means that for centuries we've been counting on the fact that the envelope of variability will not change. That is not anymore true. If you make it bigger, 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 and bigger, thanks God to a certain extent. In fact, that is less likely to happen. So Romagna is a particularly unfortunate conjuncture thing, and Valencia as well.
Thank you so much.
Thank you.
Hello. So, thank you, Professor, also from my side for your inspiring speech. And in your talk, you emphasized the need to rethink development, ethics, and distribution of resources. And in this regard, how can we ensure that future water management plans in agriculture also account for environmental costs, such as biodiversity loss, and not only focus on increasing productivity?
Well, it's a good question. I don't have a precise answer. I wish. It's so clear, theoretically and practically, that you have tools now for being able to put a price tag on the ecosystem services, to the value of natural capital. But what happens is we still live under the spell of the fact that of a development economics, everybody let's get richer. In the end, problems will decay. Inequalities will decay. This is not true. And this is one of the points which dwell into something which is deeper than that. Because if you count, it seems like a completely disparate solution, but if you count the number of times in which a certain word appears in Moby Dick, or in the Quran, or in Manzoni, you get the frequency of words that you have in the place is exactly the same. Meaning, and of course, when Manzoni, or when Melville, or when the Prophet was writing the thing, he said that they never had in mind how many times they use this word, etc. It's self-organized, critical. It's inevitable. Whatever. So this happens with open dissipative systems with many degrees of freedom. Rather than doing things completely different every single time, we do always the same thing. And that's the point. What happens in this case is that 80% of the richness is in the hand of the 20% richest persons anywhere in the world. So that's not something which we can cure easily. The fact is that if you leave nature alone, if you leave the process to spontaneous process, etc., it won't happen. It has to be the actually spontaneous processes plus the public hand. You have to direct. You have to put constraints into the system to make this happen. And what is, in a sense, disappointing is the fact that we have the tools for doing that. When the announcement of the prize was given, etc., they asked me to say this prize puts in your hands a megaphone that the world listens. What message would you like to do? And the message is exactly the one I told you. That is, the time is ripe to rethink water distribution systems, in fact, the management of water resources, as the only possible key for the reduction of inequalities. But it's a central one, because water sits at the center of history, as Bertrand Russell used to say. In search of causative factors for the history of history, hydrography is the main point, if distribution of water. And that's forever then. With the addition that good fortunes don't last forever. I keep telling my students that, and I have a small argument with the King of Sweden, in fact, in that sense, where they say, no, this doesn't touch us. Sorry, Your Majesty, no way, it happens to you as well. You should forget anthropocentric views. For instance, you say, well, who cares about waterborne disease in Italy? Baloney, because if you have like 1 degree centigrade more, all salmone will disappear from the Alps, for instance. That's a fact, which is an important one. At the same time, the point is that the erratic characters is not forever. There is a corner of the Sahel Desert, which is the driest part of the world, in which there hasn't been a single drop of water for 45 years. Not a drop of water for 45 years. If you look from remote sensing above, what you see the trace of rivers, the big rivers that were teeming with life and with water in the past. Good fortunes do not last forever. And the main character of this instability that is generated by what man has done, don't buy a second the merchants of doubt that puts doubts on the fact that it's anthropogenic. It is absolutely true that in the past we've had periods in which the temperature of the atmosphere was higher than the one we see, never seen by Homo sapiens, so as to say, in the past. But certainly, to change 4 degrees, it took 1 million years, not 100 years like it happened from the 50s of the last century to now. So it's urgent. Greta is right.
Thank you, Professor.
So we are almost running out of time. We have already run out of time, but there is still time for a brief question from the audience. If there is someone who has a question? Yeah, thank you. Can you wait for the mic, please? Thank you.
Thank you for such an interesting talk, Professor Rinaldo. Very, it made me think a lot. And I also want to sort of, argue in a small way. I understand your point about mitigation, but I also want to say that the World Trade Organization 2 decades ago called water blue gold. That is what is happening. So when we try to look at how to redistribute water, how to control water management, or whatever the right word is, how do we work with the corporations, with the 20%? They might even be the 1% of the world's population who have bought up water everywhere. In the Himalayas, Coca-Cola has taken all the streams away, and so on. You know, we can go on and on about it. So, what would you suggest for dealing with that?
Okay, we'll finish over an apéro tonight, if you'll not be delighted to do that. But what happens is that, do you know that 1 kilogram at meat at retail means 15,000 liters of water? And the point is that the value of the idea, what happens is that the trade organization are responsible for the fact that a gigantic amount of water is traded daily, everywhere. And it's something which generates all kind of pros and cons in a number of ways. But the point is that I doubt, in fact, and that's one point of the element, that is, trade is essential to that, because virtual water trade is essentially upon us, whether you don't see it, but it's absolutely fundamental, and in numbers which are mind-boggling, which is quite important. And the other thing which I really think that the idea is that the kind of but it's not that I know when they tell me, oh no, it's only mitigation that matters. I know. But we won't be able to do, you think we'll be able to do that, to give the kind of subsidies that are necessary for the, correctly so, for, can you tell a billion Indians, you shouldn't use the air conditioner, you know that, because it's, the issue of climate. You have to pay to do that. You have to find something else, or you have to find Prometheans who like to have some, like a solution, the cold fusion, whatever had been promising us for 50 years, etc. I think that one of the fundamental laws of a field I'm in, that is engineering, is Murphy's law. That is, if something can go wrong, it will go wrong. And you expect that in the political situation that you have, in which we'll have to devote part of what it goes now in welfare into warfare, do you think we'll be able to contribute to that? I think it's absolutely a safe idea to assume that whatever can go wrong will go wrong. So let's adapt. But we can talk over.
Thank you very much. Thank you all for attending this session. Thank you, Professor Rinaldo, for your speech.